the other fundamental identities that we've talked about before. So tangent, that definition, cotangent. And so often these are used in conjunction with one another. And sometimes you want to rearrange these identities in a more useful way. And so, for example, this is always true, right? Sine squared of x plus cosine squared of x always equals 1. And so I can subtract sine squared from both sides, and I can see that cosine squared is then equal to 1 minus sine squared of x, right? And so that is always true. And so if I see a 1 minus sine squared of x pop up, I can think, oh, maybe it's useful to switch that to a cosine squared. Basically, anytime you see a trig function squared, you want to at least think about using the Pythagorean identities. So here's one to try. Remember, the instructions are verify. And so we'll sort of start on this side that's a little bit more complicated. And don't see anything squared, but I do see a tangent mixed in with some sines and cosines. So I'm going to try switching the tangent to sine of x over cosine of x, and just have the cosine of x. And so now we get into a little bit of algebra with fractions, which is sometimes a little bit challenging for people. So this sine of x is like over a 1. And so when you multiply fractions, you multiply the tops, multiply the bottoms. And so this becomes sine squared now, right? And then on the bottom, we just have cosine of x. This cosine over here is just sitting there. Okay. So now what I notice is that the left side has a sum. I'm sort of aiming for this right-hand side, which is not a sum. And so I'd like to somehow combine these two things. And this is a fraction. So to combine a fraction with something else, we need a common denominator. So this cosine has a denominator of 1. So that common denominator will be cosine. So I'm going to multiply top and bottom of that fraction by cosine of x. And so that's a giant 1, if you remember that from our common denominator days. So I'm not really changing anything, just rewriting it in a more useful way. So I have sine squared of x over cosine of x. And my second fraction now becomes cosine squared of x over cosine of x. And so now they have a common denominator, and the way I add fractions that have a common, see these squares, so I'm thinking about my fundamental Pythagorean identities, and this is the big one, right? Sine squared of x plus cosine squared of x equals 1. And so now I'm basically done because I replace that numerator with 1. It simplifies things greatly. And sure enough, 1 over cosine of x is, by definition, secant of x, which is, if I zoom back out here a little bit, see the whole picture all together. That's exactly what I was aiming for. So I took this thing that was sort of messy. I made it a little messier in the middle, but making that little messier in the middle allowed me to use that Pythagorean identity, switch it into 1 over cosine of x, which is secant of x. So I am okay. I'm done. I have verified that identity.